So much for being easy to use. We'll sort this out. I'm just going to reboot it. So as I said, I started, I founded, what happened was I had a technology for analyzing fluid flow. And I was a poor assistant professor without funds, and in stumbled a representative from a company called TSI, which tried to sell me a fluid diagnostic system. And I had zero money, so I wasn't much of a sale. But what I did was show him what I was working on, and he went back and spoke to a very famous fluid dynamicist, Ron Adrian, who was a representative, who was a consultant for TSI and Company, and also very much involved in the conference here in Lisbon. And Ron Adrian gave it his stamp of approval, if you will, and TSI bought the algorithm from MIT. And that launched a product which they, much to my embarrassment, they referred to as, under my name, as Hart correlation. I have to tell you, as I was a young assistant professor, I certainly was not known in the fluid mechanics community, and to have a company stand up on stage in front of the most eminent fluid dynamicists in the world and talk about their fantastic new algorithm called the Hart correlation was a little embarrassing, but also quite flattering. And I have to say my ego got the better of me. But more importantly, it made me realize that there's another way to make an impact. And that is, there's another way to make an impact, and that is rather than simply give conferences, write papers, and hope that someone cares enough about your work to delve into it, to understand what you're doing. There's a third way, and that third way is to go out and take your technology and bring it directly to the people who can use it, and that's to start a company. And the realization that you can make an impact, not just a small impact, but an absolutely huge impact by doing that, was quite a revelation for me. And I went to the folks at MIT and I said, well, you know, I come from a background in engineering science. What do you know, is this something you would allow me to do? And they looked at me straight and they said, we don't care what you do. The only thing we care about is that you make a positive impact. We don't know how you're supposed to do it. We have no models for what it is to be a faculty member. All I'm telling you is that you should make a positive impact somehow. I'm definitely regretting this. I'm going to lecture my students to no end about never bringing a PC. So I looked at this technology that I had, and I realized that the fluid mechanics community is a rather small, close-knit community, one that I dearly cherish, but also one that was frustratingly small in terms of the people that I wanted to reach. And it so happened that about that time, I was invited to give a talk in Taiwan to an optical imaging group that was doing video games. And at the end, and I wondered why on earth they would invite a fluid dynamicist. You know, I didn't have anything in common with them. At the very end of the talk, I presented a slide that showed how my algorithm for registering images could be used for three-dimensional imaging. Now, my algorithm was about 100,000 times faster than the closest algorithm at the time. Keep in mind, this was about 1996, and PCs were you know, fairly crude back then. Better than Macs. But the issue was that they could not, they wanted real-time 3D. They wanted to be able to put a camera on your computer and be able to take your face and your expressions and put it into the characters on the screen. And I didn't hear from them for 3 years. And about that time, I was up for tenure. And I got invited to the dean's office. And so I crawled to the dean's office, and expecting to get fired, because that's how you get fired at MIT, and it's not an uncommon thing for an assistant professor to get fired. So I show up and he says, well, the proposal should be about 15 pages long. And I looked at him and I said, proposal? He said, yes, your proposal to the Ministry of Economic Affairs in Taiwan. And I went, huh? And it turns out that without writing a word, I was given $1 million in research funding to do something that I'd already had for fluid mechanics. And that got me inspired into, well, what happened ultimately was we built a stereoscopic camera system. It worked. We went to SIGGRAPH, which is the biggest entertainment conference in the world. It was held in Los Angeles that year. We were right next to Pixar and DreamWorks, and Shrek was being released. And we had a line that went out the door and around the block because we were giving away 3D images of people. And so they all lined up to get their picture taken. We could do video rate 3D measurements. But I had this crazy idea. This was that what happens is, as we took these two cameras, I kept moving them closer and closer together because I could run faster and faster, and I didn't need the accuracy. And eventually the cameras hit each other, and I couldn't get them closer. So I had this idea on how you could create a 3D imaging camera from a single camera. In fact, something that you could bolt on. And out of that came a very unusual technique for what I called active wavefront sensing. And there was a similar technique being evolving in a different way at Stanford at the same time, but I didn't know that, fortunately. Being a fluid dynamicist, I was blissfully ignorant of many of the machine vision world. But I gave up the $1 million research grant in order to do it because the Taiwanese did not believe that I could succeed at this. And I was so set that this was the right way to go that I gave up that grant. After spending considerable amount of it, I might add. But then I was left with 3 graduate students and no way to fund it. I opened up my email, and lo and behold, what happened? There was the Deshpande Center soliciting for the very first proposals for technology that could be commercialized. So, yeah, you can see, yeah, so of course, as a fluid dynamicist, I go into machine vision where it's nothing but computer work. But I had this vision for how to capture 3D at video rates. And I wrote a proposal, and it was around 2001, 9/11, and I had this vision of doing it for facial recognition for security reasons. I believe that was where the application was. I was wrong. It turned out. It turned out the application was in dentistry, of all places. I'm a fluid mechanician who's working in mechanical engineering. And I would never have dreamed that dentistry was where the final market was. But lo and behold, it was. And so I applied, and I received funding. Why, I don't know. But I'm very grateful for it. And it was a high-risk endeavor. It was a very high-risk endeavor. But it worked out tremendously. What happened was we formed a team. A very wise person told me that I don't know squat about business, and I better find someone who does, because an engineer can't form a company if he doesn't know how to do market studies and so forth. So I was led to the MIT 50K entrepreneur competition, and I met 2 Harvard MBAs there, who then became my partner in the MIT 50K. We ended up being runners-up. Not winners, but runners-up in both the Harvard business competition and the MIT 50K competition. From there, we pitched to venture capitalists. Thank you. So now it won't run. This was the first product, as I said, TSI purchased. This was a conference here in Lisbon, and I don't know why it's now off the screen, but it is. Believe it or not, that says 1996. I'm just grateful it's up. That was the first fluid dynamics. Let me flip through here rather quickly. This was the first product. We had a stereoscopic camera system that imaged objects in 3D. It did it at video rates. in 4 dimensions. Yeah, if you can hear. This was the single camera, single lens system that we proposed to the Deshpande Center. In fact, this was the system we built with the Deshpande Center money. And it has a module that fits between a camera and a lens, and you can aim it at a crowd like this and capture 3D on a laptop screen. So when we first realized that we really had something, when people saw this, and everybody that came in the door said, I have to have it, I want it, where can I buy it? And that was what started us. As it turned out, that wasn't good enough, because the market was so highly fragmented that there was no way to create a business with that. Thank you. I formed a team of mostly my students off in the corner, which Manuel might recognize as Janos Rohai, who was a postdoc for me at the time. And we were runners-up in this. And we formed the company in 2004, the early stage, called Brontis Technologies. Let me give you a timeline. Unfortunately, so the initial concept was from 1999 to 2003 for the active wavefront system. In April 2003, we won a competition much like this. Not quite, it was a business plan competition. That's certainly not guarantee of success or financing from venture capitalists. But in June 2004, we received venture capital funding. We received $5 million. Series A from 3 of the prominent companies in the Boston area. The most prominent being Kodiak, which you'll hear about next. In 2005, we had an alpha system I'll tell you more about. So it took us almost a year to get the technology to the point where it looked like something that might image teeth. And in 2006, we had a beta unit, which was starting to look like a dental instrument. And off in the corner here, in the end of 2006, we sold to 3M for $100 million. We were still in Series A, and the company was only 2 years old when we decided to sell. The board evaluated us at $15 million. We said, we're worth more than that. They said, no, you're not. We said, well, let's go out and find out. And we did, and we got 3 offers in the $100 million range. Just the market we ended up going after was not one we expected. It turns out that dentistry has been looking for an instrument that will do what this thing will do for quite a while. The current process of imaging teeth is they do castings of teeth, and it's a very inexpensive and unpleasant process. And the catch line we used was no more guck. It seemed to resonate with people. Currently, actually this slide says 2006, it was 2007. There are 37 people, and 28 of those were engineers. But it certainly was not an easy process. So when we went out for venture funding, we have these wonderful comments. Basically, the VC community was not enthralled with us. They said the dentistry market was very fragmented, very difficult to wrap your hands around, and consequently, they didn't quite believe in our success, at least not all of them. So even in the technology was at an early stage. Teeth are extremely difficult. They're wet, they're translucent, they're in your mouth. It's the hardest place there is, and nobody had an instrument that could do this. And we were fluid dynamicists. We were not machine vision people. So it was a hard sell. We were in the development process for over a year when suddenly we realized that the only way we were going to get to image teeth is if we could coat them. This was our first attempt. We called it sticky black. It was not a great success. Fortunately, we figured out a way around this, but like I say, it wasn't an easy process. Our first alpha unit, it had a bad habit of electrocuting whoever used it. You could barely get it in your mouth unless you had a huge mouth, so we used our Harvard MBA student here. It used to leak water, which is why it electrocuted people. It overheated. It would burn your mouth if you put it in it. So that was our alpha unit. Our early scan, brace yourself, this is really stunning. That was our first scan of teeth with our alpha unit. Okay, not exactly. So about this time, the board is panicking. They keep looking at me and shaking their head and wondering, how they could. I hear them whispering about how they can exit and still save face. But things looked up. So we went from our alpha unit, we developed a beta unit. The beta unit was nice. It was a very compact system. It was a wonderful little toy. We took it to the dentist's office and we asked the dentist to use it and see what they thought. The problem was that dentists didn't want to buy 10 of these things. They wanted to buy one, and therefore it became a problem. They didn't want to cart it from place to place. So we ended up building a cart, which is on the right, and that was very close to the final system that we ended up using. We introduced them into offices. It was a huge success. There's actually more of these units in Europe than there are in the United States because of insurance laws. Yeah, very successful. There's a movie to this, but it's not going to play on this machine. But that's the final unit. This device was accurate to 5 microns, if you can imagine that. It's one of the most accurate 3D imaging systems available. It's handheld. There's no laser scanning. It's completely passive imaging system. It looks like an electric toothbrush, and you basically just wave it over the teeth and you get a full rendered model in real time as you go. If you can imagine, that's a point cloud at the top, and that's only 1/10 of the data that we get. So I've been asked many times, having gone through this process and learning in the process that the average startup never succeeds, that the chances of success are slim to nil. I don't mean to inspire you here. Would I do it again? And the answer I had was a resounding, doesn't show up on the screen, but is a resounding yes. In fact, I set out and did it just again. I always said that if Brontis had failed miserably, I would have succeeded tremendously because of what I learned and the experience I had. It was a real eye-opener. It changed my approach to academia. It changed the way I teach. It changed the way I mentor students, and it changed my outlook as an engineer. So from that was the biggest success for me. The money didn't hurt. So lessons I've learned from the process. You cannot do a startup alone. The odds are against you. You need every bit of talent you can possibly get your hands on. And the way you do that is you go out and you find good people. But you can also go, there's just a wealth of people willing to sit down and talk with you. Almost everybody we met was willing to sit and spend hours with us discussing our strategies, how we go about, what our weaknesses were, and in fact, one of the people who helped us the most is sitting here and will speak next. Your critics are often your best source. You should seek out your critics because they are the ones that are going to help you the most. You don't want people telling you, oh, great, wonderful. Those aren't going to help you at all. Seek out your critics and listen. Talk to potential customers. Your customers are the experts, not you. You need to go to the customer, you need to ask them what they want, and you need to give them what they want. It's really quite simple, but it's hard to do. It's not in the soul of an engineer to go do that. But once you get 2 people in a room, they'll tell you a tremendous amount, and there's no better source. And then the final one is adapt or die. As I said, I set out to do machine vision. It's what I dreamed would happen. That's not where the market was. I didn't know. I never dreamed I'd end up in a dental imaging company, but that's where the market was. So rather than be stubborn and pig-headed about it, I followed it, and that's where I ended up. I learned one other lesson, which I was teasing Andre about earlier. I learned that VCs never wear ties. But he showed up in a tie, so obviously I didn't learn my lesson very well. So, anyway, thank you very much, and sorry for the trouble.